Alright guys, it looks like I'm live. So I have not done a webinar in a while because of my other laptops breaking up. I'm going to be using this temporary computer for a while so I can webinar for you guys. Today I want to go over performance bounceback. Pretty sure many of you have already completed it, but for those that have not, I hope this can help you out by giving you some tips on how you can complete it pretty quickly, as well as like the tools you can use on Unity. Okay. So if you look at the different projects we've worked on in the past, we have Puzzler, which is a very design-oriented project. They have you write up like a write-up for the project and turn that in. And then for the next one, which was the Rube Goldberg game, it was very focused on the development aspect of like the technical aspect of development, wanting to emphasize on the different types of design tools and basically programming for one sec. Sorry about that. Okay, so the Rube Goldberg game emphasizes mostly on the development aspect of game development and VR dev, while Puzzler focuses more on the design aspect. And then finally, for the performance bounce back, we have a project that's emphasized mostly on the optimization aspect and the performance of the project. So this is going to be mainly based on polishing up your game, the final product, when you're nearly done. Checking like the lighting settings, the rendering settings, as well as like the different types of performance issues that might be inside of your game. So hopefully this project should resolve many of those issues that you have. And let's go over the rubric really quick, okay? So for the performance bounce back project here, we have the rubric. And the main thing I recommend for this project is to read over the rubric before you actually begin, because just like all projects, right? But for this one especially, because this project is mainly focused on wanting you to do like several things. Like there's a specific task that they want you to do. You want to remove all trampolines or lights and have the balls spawn every 0.5 seconds. And then by picking up and throwing the ball at the trampoline, then that will increase your score on the scoreboard. And the score should be visible from the starting area. That's the first specification. So it's pretty straightforward, I would say, this project, whereas the Rube Goldberg game and the Puzzler are a little more open-ended. This one does have specifications on what you have to do, so you definitely want to be reading the rubric as to what you should be doing, okay? So that's the first specification. The next one would be for batching, making sure that you're turning on dynamic and static batching as well. You basically just have to go to the player settings, going edit project settings, I believe, and then you go player, and then you can turn this on. Statically batch visible game objects never move. You want to make game objects that never move to become static, and the reason of this is because objects that are static and don't move basically save a lot of performance. That's kind of why you specify it as static. Yeah, basically, if you have an object that's not moving, by listing it as static, it's going to save quite a bit on performance. However, if you have a object that does move and you list it as static, then it's not going to be able to move during runtime, so that's not what you want. You want to look for those that don't move and then list those as static. Let's go in the project really quick. I can show you these different settings. Okay, for the first one, let's go to batching. You basically go edit, project settings, and then you go to player right there. I should open that up, and then here you should modify it. You can modify its settings right here. Look familiar? Well, let's see. Dynamic static batching options. Oh, right there. See that? Make sure that you're checking those two. And if they're already checked, then you don't have to do anything. Yeah. So that's where that first one is. Let's take a look at how we can make objects static. So I'm going to create a cube here. So if I have this cube move, maybe through rigid body, having it fall. As you can see, it moves, right? But if you make it static, what then happens is that it's not, oh, it doesn't move, huh? Well, I think if you move it using your code, it shouldn't move. I'm not sure why that's moving. Okay, anyway, regardless, if you have an object that doesn't move during runtime, you want to list that as static, whereas if you have an object that does move, you don't want that as static, okay? So yeah, pretty straightforward. Make sure you're doing that. They're going to be checking for that in the project because you're going to be submitting the entire project, I believe. You're going to zip up the file and then put it under submissions. Okay, cool. So next is the physics update rate. This is essentially how many frames you want the physics to update. So in this case, you actually want it to update at a rate of 90 frames per second because this is VR. If it was like regular PC game, that would probably be 60. So since you want it to be 90 FPS, you want to go to edit, and then you go to project settings, and then you go time. So to fix this, all you have to do is modify the fixed time step, and then if you do the calculations, the value ends up being 0.011111. Yeah, and then that should give you your physics or your update 90 frames per second. Next is rigid bodies. Okay, the next thing you want to do is make sure that all moving objects with colliders, make sure they all have rigid bodies on them. If you have a moving collider, put a rigid body. Okay, it's pretty straightforward. Moving objects are also not marked as static, as I mentioned before. And then here we want to remove unnecessary rigid bodies from non-moving objects. So if you have this cube that's not moving at all, you want to take out the rigid body. But if you have this cube with like a box collider on it, as you see here, and it's going to be moving, then you want to add a rigid body. Okay. So for instance, inside of the Rube Goldberg game, like the ball that you're going to be throwing, that's going to have a collider as well as a rigid body. However, I believe the trampolines, I don't think they're moving at all, so you can mark those as static. Oh wait, no, I think you have moving trampolines. Sorry about that. But like the floor, the surroundings, anything that's not moving, you can mark those things as static. Take out any rigid bodies on them. And yeah, just make sure everything moving has a rigid body. Okay. Next we have objects. So object pooling, I believe they go over this in the lessons, but essentially what object pooling is that it's replacing the function instantiate and destroy using object pooling for spawning the ball. So instead of calling instantiate ball every time and destroying the ball after you throw it, because that takes up a lot of performance, those two functions. So rather than doing that, you can actually do it a different way using object pooling. And essentially what this is rather than destroying it, you're going to be setting the ball active to false. So you're going to be rendering it invisible basically. And then you're going to have it circulate back to the where the balls spawn, and then you're going to set it back to set active back to true. So yeah, in this case, you're not really destroying it and creating it. You're kind of recycling it in a way. And that's what object pooling is. For code, we have caching. Make sure that you're storing the variables and references when there's a change rather than creating and updating them every frame. That's pretty important. For a lot of instances, when you have like a script attached to like a ball or something, a lot of times you're not really going to be reusing or rechanging like the references during runtime. You're only going to be referencing to one object throughout. So in those cases, what you want to do is you want to actually put the reference to the object in the start function rather than update, because if you put it in the update, it's going to have to extract that reference every single time, and that's going to take up some performance. So once this will load up, I'll show you that. Okay, so let's say I want to get a reference to a rigid body. Okay, and then let's say I want to call upon its reference in code. So I'm not going to be referencing it through the editor, I'm going to be referencing it through code. And let's say the rigid body is conveniently strapped onto the object that the script is attached to. So instead of putting it in the update, because the update's going to be updating like 90 frames per second, right? And then basically you would have to call get component each time, which takes up performance, of course, because you're trying to get a new reference every time. Rather than doing that, you want to list it one time at the very start by calling ball rigid body dot get component, equals get component rigid body. And what this is going to do is it's going to extract the rigid body, that the object that the script is attached to, and it's going to store it in this reference right at the very start, so you don't have to worry about calling this later on. You can just call ball rigid body dot move position and yada yada yada. Okay. Alright, so that's caching. Next we have code cleanup, and this is essentially removing code that will not be used in a final release. Also very straightforward. The main instance I see this being used is by calling debug.log, because debug.log is for, of course, debugging. So you're going to have this all scattered throughout your code, especially in the starter project. You want to basically just delete them when you're sure that your product is finished, because debug.log actually takes up performance as well. Okay, so you're not going to need that in the final product. You can just remove that. Frame rate, make sure it's running at consistent frame rate at 90 frames per second with no frame rate drops below that. You can, to find whether or not your game is running at around 90 FPS or greater, you can use the profiler, and I'll be going over that later. For now, I'm going to go over the different specifications. Okay, so next we have lighting. We want to have the lighting rendering path to the one recommended for VR. This is going to be specified in the videos. Make sure to watch those, and there's going to be a pretty detailed explanation on what each type of lighting does. This is basically the way objects are computed using lighting. Yeah, so in this case, just go watch the videos and then check that out. To change the different settings, you just want to go to the graphics settings. You just go here, and then you go graphics. And here you should be able to change that. Let me see, where is it? Oh, right there. Okay, so if you open the window, yeah, you can actually change this. I'm using a older version of Unity. I think on yours it might be a bit different. Basically, you just want to modify the rendering path here to the one recommended for VR. Okay. Anti-aliasing, we want to enable 4 times or 8 times anti-aliasing. You just I believe that's should be graphics. I don't know. No, could be in quality. Check that out. Oh yeah, that's it. So here for VR, we want to have 4 times or 8 times multi-sampling rather than 2, just because of how VR is designed. You want it to be more clear, okay, like the text. And then baked lighting. You should know what baked lighting is. Baked lighting is essentially just computing the lighting before the scene actually renders and before real time, so you can reduce the real time performance cost. So yeah, it's just pre-computing how the lighting is on objects, right? So you don't have to compute them during runtime. And then I think you should know this, but this is inside of the lighting settings. You go that through window, I believe, and then lighting right there. I like to move that here. After you move that there, then you can modify its settings. Here's real time, and then yeah, here is I believe that's if it's baked. If it's the lighting is specified as baked, you can auto generate like that for debugging. Yeah. Okay. Yeah, for the lighting itself, you have to specify how you want it. So for the point light I have here, you can specify if it's baked or if it's real time. For objects that are not moving, you want to specify those as baked because it's not really going to matter as much. Whereas if you have real time, you kind of need to compute the lighting because the object is moving and updating every frame. So yeah, as a simple rule, just for the objects that are not moving, just have them baked, and then moving objects moving, have those become real time. Okay. And then finally we have light probes. Light probes are basically giving your game's moving objects lighting. Oh yeah, that's also another way to do it. You can basically use light probes instead as your real-time lights, and then you can basically set that up so that you're covering a lot of area at which the moving objects move. So to create a light probe, you just go to light probe group, and then here you can modify these different light probes. Okay. They go over this in the video as well. You should, yeah. So you can watch that. Alright. Let's see. Oh yeah, you can make it stand out too. So these are just extra things that you can add for your project if you'd like. You don't have to. You can add a timer, you can add some sounds, customize some particle effects maybe, create a button that resets the score. Yeah. Okay, these are just some development features that you can add. Yeah, they're fairly simple. I mean, if you want to add them, definitely go for it. Alright, let's go to the actual project itself and look at the different analysis tools that I believe will be helpful for Performance Bounceback. Before you submit the project, I believe it has to be running at a certain frame rate. So they give you like a starter project that has a bunch of issues, performance issues that you have to fix, and then in order to do that, you have to understand how the different analysis tools that Unity provides for you to look at the frame rate and stuff. Okay, so I believe in the video inside of the course content, they cover over the two analysis tools. I'm gonna try to find it really quick. Where is it? Rendering. Oh, right there. Okay. It's weird. Okay. Yeah, I might be using an outdated version. That could be why, huh? Should be here, I believe. Not sure why that's not showing. Alright, let's just try to download the latest version. I think I should fix it. Alright, this will take a while. Let's download Unity Hub first. Yeah, I'm thinking that the analytics tools that are not present in this version. I'm using a pretty outdated version, 2017.4.2. Yeah, I'm not really sure where the analytics are here. Oh, there. That's the profiler. There should be other tools though. Oh, here. Okay. In that case, I don't need to download this. I found it. But I believe in the newer versions, they actually put these, they organize it a bit better. They put it under analytics and then you can select them. But in this case, we have it right here. The three main tools that I use for debugging as well as optimizing my game are the frame debugger, the physics debugger, and the profiler. So if we look at the frame debugger, this has been gone in the videos, the course content. It's pretty straightforward. You just play your game, and then whatever kind of frame you want to capture, kind of like a camera, you click enable, and that's going to give you like a detailed description of what objects are being rendered and how many draw calls your camera is making. So as a simple rule of thumb, the bigger the number is, the more performance it's going to take up. The less the number, then it's more optimized. Okay. Next, we're gonna go over the physics debugger. This is not gone over in the course, but it's quite helpful, especially if you have something involving ridge bodies and triggers, and you want to like organize and see like the specific objects. So if you have like a bunch of objects in your scene, you can actually hide all the objects with ridge bodies, kinematic ridge bodies, even triggers, colliders, etc. And this can be done during runtime too, so it's pretty cool. And that can help you take a look at your scene and then analyze it. Okay. Finally, I think the most important too is the profiler. So the profiler is pretty cool. What it does is it gives you real-time data on how your scene is performing, and it gives you like the frame rate at which your game is running at. So if I'm playing the game right now, it should be pretty optimized. There's nothing really much going on. There's just a cube and a point light. Let's run the game, and then it should record like the data here. So it says that it's running at, let me see if I can try to zoom out here. Okay, I guess not. Well, here it's running over, I believe that says 80 frames per second. So because it's between 80 and 100, I'd say it's around maybe 87, 88 frames per second. You want to kind of take the level out, the average, put that as your average frame rate. Notice there might be some peaks, like here, right there, for instance. You don't really want to capture the frame rate at that point. You want to capture it like at the average. So those spikes are not going to matter as much. You just want to see how overall how well it's doing, and then use that frame rate as your target frame rate. Okay. Also note that using the profiler itself is going to take up some performance as well. So just know that when you run the game outside of, like, when you're not using the profiler, it's going to be running at a much smoother rate. It's going to be a bit lower. But of course you're not going to know that because you can't analyze that. So I guess you can just make a guesstimate on how much RAM that's going to take up. I believe you can also check out how much it's taking up here. I think under others it should give you a description on what's using that. So to read basically read what it's like this graph right here, you want to take a look at how big each color code is, and the bigger it is, the more performance it's going to take up. So in this case, yellow is occupying a great amount of space versus the others, and that's going to be under VSync, under the color code. Here the green one, that's going to be rendering, I believe, and rendering is not going to take up that much because we don't have much to render. And then if you have a lot of scripts, then that take up performance, it's going to be blue. And you can even isolate them, check out how they're doing. So here you have scripts, rendering, and then you have a little bit of scripts, it's not much, and then some physics as well. Garbage collector is going to be like destroying like the object, which takes up quite a bit of performance, surprisingly. And then you have these other ones, UI, global illumination, you have others. Okay, others is going to compose of like using the profiler itself and just other things in general. If you want a more deep analysis on what's actually happening in your scene, you can click deep profile and then run the game, and then you can take a look at let's do that again. Right, and you can take a look at each frame. You can even choose which frame you want to examine. Yeah, note that after you stop the game, it saves for you, which is pretty cool, and you can analyze like the different types of frames. And here it gives you like a description on how many milliseconds each process took up. So we have 0.15 milliseconds, which is for scripting. You have 0.01 milliseconds for others. Or no, sorry. Is that others? I don't know. Yeah, just check the colors if they match. Yeah. And then here you can examine like what's causing like what's taking up the most performance. So a regular profile is not gonna look through everything, all your functions and everything, while the deep profile will. It's gonna look through all your code, and it's gonna check for what's taking up the most room in the optimization aspect. So here we have 57%, which is player update time. Oh, that's because of making it the fixed frame rate thing. I think that's why. And then here you have other tools that you can use to analyze, like rendering, memory, allocation, audio, which is pretty cool too. You have video, physics 2D, network messages if you're dealing with network operations, UI details, global illumination, etc. Yeah, the profiler is pretty cool. I recommend that you check it out and experiment with it. There are quite a bit of things you can do with it, which is pretty cool. Okay, so yeah, that about wrapped up my my webinar for for the performance bounce back. I hope I went over much of the things that you're gonna encounter when you're doing the project. This is still downloading. But yeah, if you have any questions at all, don't hesitate to let me know through Slack. I should be available this weekend. Yeah, I believe that most of you have already finished the project, so I'll be actually starting a webinar the very next week, because I haven't been doing a webinar for quite a while because of my laptops breaking and all. But yeah, hopefully I can do another webinar soon, and hopefully by sometime next week. Yeah, that's what I'm hoping for. So yeah, anyway, any questions, just let me know. Otherwise, I'll just be on Slack. Okay. All right, goodbye.